Hello everyone, this is Mike from the Professional Amateur channel again. Well, today is a Monday and this is about lunchtime, and I'm trying to microwave some leftover for lunch, but I guess I'm crap out luck because my microwave just broke. And this is what it does when I actually try to microwave. Say 2 minutes, start. The light is on, the timer kicking in, and it, counting down, but the turntable doesn't turn in the microwave. Nothing happened. Not a dang thing. No buzzing sound, like the microwave is not even running. So, being hungry and no food, I have decided to skip lunch and take the microwave apart and see what happened. So, let's do it. I have relocated my microwave onto the floor where next to the outlet, so I can actually do troubleshoot. Before we start, I want to clarify that I do have some background in electrical. I was an electrician in the Navy for 10 years. Screwdriver. Take out the screw and pull it right out. So this is the turntable motor. As you can see, before you actually touch it, make sure that the microwave disconnect. What we're testing for the turntable motor is the resistance. We want to make sure that the motor coil do have some sort of resistance. One common mistake that a lot of people people do when they testing for motor, they checking the motor to make sure it's good or bad, is that they testing for continuity of the motor wire, where this is not correct. You have to test for resistance. As long as there's some sort of resistance on the motor, that would actually indicate it's good. This is the meter that I'm going to use. This is a fluke meter. As you can see right now, I'm actually setting it to resistance testing. When any motor coil that reaching down to 0.1 ohm, that means the motor is already bad, because there's no resistance within the coil. We loosely call it a shorted motor. In order for the motor to actually work, the coil have to have some sort of resistance in the wire, so that when electricity flow through it, it generates a magnetic field. Now, let me switch over to the resistance test. Let's see how, if the resistance test reading OL like this, that means it's already bad. The motor coil is bad, but not yet. Let's see how many ohm we're gonna get here. Sorry, I haven't actually do any electrical stuff for a long time, so my hand is a little shaking. As you can see, I got 119.6 ohm. That's an indication of a good motor, for sure. So with that being said, it might be the door switch, that the door safety latch and switch, that might be the problem. So let me connect it back, and then I'll close it up, and we're gonna move to taking this big giant microwave apart. I'm suspecting the door switch, with the actually holding the latch and assembly right here, that actually go bad. We have a couple door switch right here. Let me actually take the camera out, and I'll do a little close up. So you can see here, there's one right here. This is one of the switch, and then the second one is right here in the middle section. You see the little lid connection, and then the bottom one, there's a bottom one right there. So let me start from the beginning, and then I'm setting the fluke meter to continuity. Okay, it's right here. There you go, you see? You have the beep. This is when the microwave door closed. So look like this one is good. Let's put it back before I forget to reconnect it. So for the second switch, maybe you guys can see it from the video, which is right here. In the back right here, there's two little lid. Also need to actually disconnect it. Let me pry it up a little bit using the flathead screwdriver that I have on my hand. There you go. To expose the middle terminal. So there you go. With this one, it's not. This is what we call normally closed switch. So when it's before it activated their path going through. But when you actually when the microwave door closed, when you activated the switch, it become open circuit. It will send the power to a different route. Without getting too much into the detail here, let me continue the test. So as you can see, this switch is activated. Isn't activated, but they are continuity. So let me try to activate the switch. So once I activate it, it should have been open and the continuity stopped. There you go, you see? So when we're testing for stuff like this, we just want to make sure that the switch does cycle. There you go. So the second switch looked to be good. This is where the, you guys see that? This is where the switch is. Let's test the continuity on the switch. Let me actually disconnect this cable. Let me stick the test lid in here. And see, as you guys can see, there are no continuity here. And let's see. Let's activate it. See, activating it. Nothing happened. See, that just basically mean one thing: the switch is bad. It doesn't cycle. So look like I have to actually order a switch on Amazon and get it shipped to me next day and replace it. And I think the switch maybe cost like $5–10. I'm just gonna go and order it. I'm not even putting it back. I just leave it, open and shove it in the corner. Order the switch, and when it comes, I'll replace it. But anyhow, I hope you guys have a good day and stay safe. Until then, see you. This is the switch. It looked exactly the same as the one I actually had in there, the defective one, and then all the lid look pretty solid. And I actually tried to jerk it around. It's stable. So now let's go over to the where I put the microwave. Here. See here, this is where I left off a couple days ago. And I took it apart. Didn't even bother to put it back, so I lived 2 days without microwave. With that being said, let me actually try to test the switch here, make sure that it, works. Okay, now, with the camera docked on the camera stand, let's do the test properly. As you can see, before, this is the switch where it's activated, right? No continuity. Let me set this over here so you can actually see. Okay, should be able to stand sideways like this too. There you go. So you guys can see the meter. Yep, it's OL. It's set to continuity. And this is the switch where we're gonna put the test lid on the terminal right here. See, now it's not activated, so it's OL. Now let's activate it. See, when you activated it, wow, it's really good switch. 0, 0, 0. See, I took it out. It's quite easy. I thought it was hard. But no, I was wrong again. See, this is the old switch. It looked all burned up. You see all the burning right here? The little like grease. And then the terminal got loose. And then also there's a little burning right here. This is the new one that actually worked. Let me take the camera down and then I'll show you guys the close-up on the little latch that actually holds the switch in place. So right here, this is where the switch located. At the bottom, there's a little latch right here. You can actually see my screwdriver. The little latch. It's spring-loaded. You push it in, right? And then you push the latch in using a little flat tip screwdriver, and then you push the little switch downward, and then it will become loose. Let me actually put it back to demonstrate. So naturally, the switch sitting in this position like this, right? So it's sitting up like this. With the top part right here, the little pin right here, hold it in the front end, and then that little latch right here, as you can see, hold it back on the back end, so it would actually sit all the way up and even. So when you want to pull it out, you would actually use the screwdriver flat tip, push this little latch right here inward so that it doesn't actually latch the switch no more, and pull it down like this. As you can see the switch right here, right? We actually slide it up, push it in, and there you go, it slide right in. Very easy and straightforward. And that's it. It's hard to do actually recording and working at the same time, but that's how to do it. There you go, let's connect it back. And before we actually do anything, I just want to test it. Make sure that it works. Let's plug this into the outlet right here. Anyhow, you guys heard a kaboom, call 911 for me, please. I'm just kidding. So, there you go. If it worked, we should actually hear the little rumbling. So I'm gonna set to 20 seconds. Of course, you know, there's nothing in there, it's empty. But we'll see. If you hear the rumbling, it should actually work. 20 seconds. There you go, the fan kicked in, the light's on, and we should be good to go. Now, let me put the rotor assembly tray back. The turntable assembly tray. There it's in, and it's in. Whee! Let's see. Let's start. So now you can see it actually turning. I just saved myself $300 maybe, and a trip to the store. Here you go, let me put this together, and it's considered mission accomplished. This is where my microwave belongs, and let me actually do a test. And since, you know, I have to skip lunch to actually like fix this thing, and this is my lunch. Here you go, let's go for 20, maybe 45 seconds. Just 40 seconds, who cares? Here you go, it's actually spinning. Anyhow, you know, with the microwave fixed and now my lunch is ready, I guess I'm gonna go snack it off. Until then, hope you enjoy the video, and thank you for watching. And I'll see you in the next video.